Well, hello everyone. We're gonna finish talking about related rates. We did a few examples the other day in class on Wednesday. They're pretty geometric examples. I remember we did one that involved volume. Today we're gonna look at more of the word problem type problems. The first one I had was problem 22 on page 250. If you need to, this sheet will be uploaded on Blackboard, same with all my other sheets. But it says a boat is pulled onto a dock by a rope attached to the bow of the boat and is passing through a pulley on the dock that is 1 meter higher than the bow of the boat. If the rope is pulled at a rate of 1 meter per second, how fast is the boat approaching the dock when it is 8 meters from the dock? Alright, so if you look at the picture in the book, it looks something like this. Oops. Here's my fancy boat. Here's the pulley. And then we got the dock that's up there. And then the rope is attached to the front of the dock, of the bow of the boat, all the way up to the edge of the dock. Now, if you were to look at this, you would probably see, you could see a triangle right here. And that's what we want, okay? And we want it to be a right triangle because we want to use an equation, a special equation. We're going to use Pythagorean's theorem. So what I'm going to do is I'm going to erase this picture, I'm going to take the triangle out and blow it up a little bit, show you what we're doing. Okay, so there's our triangle, right triangle. And now, since it's a right triangle, we have some relationships that we can use. Now, in a later problem, we're going to use some right triangle trigonometry to solve it. In this one, we're going to just use Pythagorean's theorem. And if you remember, if I label this side x, this side y, and this side z, Pythagorean theorem says x squared plus y squared is equal to z squared. Okay? So that's the equation that we're going to use that relates to this problem. Now what we're going to do is write our givens, write what we know. Now if we look back in the problem, we could see that the dock is 1 meter high from the bow of the boat. Now, when they want you to find the answer, they're asking how fast is the boat approaching? Remember, the boat's going to be over here. How fast is the boat approaching the dock? So they're asking us to find dx dt. That's what we're looking for. But how fast is the boat approaching the dock when the boat is 8 meters from the dock? Now, they also tell us the z component. Now, they're saying the rope is being pulled in. If I'm pulling in the rope, I'm pulling in this direction right here. So they tell us what dz dt is. dz dt here is 1 meter per second. Now, if you look here, we've got dz dt, dx dt, that's what we're going to try to find. They don't tell us dy dt. I'll give you a moment to think of what dy dt should be equal to. Go ahead and think of an answer. If you can't think of one, that's okay. Give it your best guess. Okay, so now, as I pull this boat inward, as I'm pulling this rope this way, this distance is going to get shorter. The boat's coming in this way, this distance is going to get shorter. But the dock never changes its height. Therefore, dy dt is going to be 0. Now, we are also missing another piece of information on this triangle. We've got x, we've got y, we don't have z, okay? Now, how to get z, we've got this relationship up here of the Pythagorean theorem, So if we just take our x, plug it in, take our 1, plug it into y, you're going to find out that z is equal to, now I'm just going to give you the answer, it's square root 65, and our units here is meters. Okay, so now we have everything to be able to, all our information to be able to solve for our dx dt. So I'm going to write all of our givens over here, and then I'm going to erase the picture, because we really just need this equation here. Okay, so let's see, x was 8 meters, y was 1 meter, z was square root 65 meters, dt was equal to 0, we got dx dt, we're trying to find, and dz dt, that was 1 meter per second. Alright, so there's all our givens. Now let's go ahead and we want to find a rate. Remember, these are related rates. If we know some rates, we know these rates, we know what instances they occur at, we could find another rate. Now we're going to do this by implicit differentiation, just like we did the other problems. So I want to implicit differentiate this. So differentiate x squared, you get a 2x, and then don't forget your dx. And then differentiate y squared, you're going to get a plus 2y, again, don't forget your differential, your dy, is equal to 2z dz. Okay, now, if you notice that this has a 2, this has a 2, this has a 2, so what we can do is we can just go ahead and cancel those out. Now, not only that, in this same step, as you see, I'm limited on board space. So in this same step in green, I'm going to divide by dt. Now, let me go ahead and rewrite this equation so it's not as cluttered. We've got x dx dt plus y dy dt is equal to z dz dt. Now, we could use one of our givens right now. We know dy dt is equal to 0, so this entire term right here cancels out. And now we want to solve for dx dt. That is our goal. Remember, dx dt equals question mark, how fast is the boat pulling into the dock? Now, with this piece gone, we just have a single equation, and if we want to solve for dx dt, all we have to do is divide by x right here. Okay, I'm going to erase the top. I'm going to keep this bottom piece, erase the top, and rewrite our new expression up there, our expression for x. So, now we have, or sorry, I said x earlier, I meant dx dt. dx dt is equal to, we've got z over x times dz dt. Well, we know what z is. It's square root 65. We know what x is. It's 8. Times by dz dt, which is just 1. So this becomes a very easy multiplication. And it's just square root 65 over 8. And since this is a dx dt, think about the units. The dy's dt's, dz's dt's were all meters per second. So this should be meters per second. And here is our answer. The exact form of the answer. You can plug in your calculator. You should get a little bit over 8. Okay.